We present our work generalization of word models under environmental variability for vision-based quadrotor navigation. A word model predicts what happens next given a sequence of action, letting us train the policy in this imagined world and reducing the number of simulation steps needed. But when the environment changes, do these predictions still hold? That's what we address in this work. We study this in 3 stages. First, data collection. The agent explores the environment using a range of strategies, recording depth images, states, actions, and reward into replay buffer. Data is collected independently at 4 levels of environmental randomness, from a fixed layout up to the fully random placement. We train Dreamer v3 that learns the environment's dynamics by self-supervised reconstruction. The result is a latent space where the agent's state and depth are all encoded, as visible in the PCA plot on the right, where points colored by the distance to the target are organized cleanly. Last stage, an actor and critic are trained inside the word model. After a brief context window of real observation, the model rolls out entirely in imagination, hallucinating future state and depth from its own latent dynamics. The imagined trajectory tracked the real one closely in simulation, even in imagination. We present real-world closed-loop navigation. First, we deploy all trained word model navigation policies on a real quadrotor in an unseen environment. The corridor consists of 7 cuboid obstacles, in contrast to 5 obstacles used in the training. The models that generalize well during self-supervised pre-training all succeed, passing through gaps barely wider than the quadrotor itself. However, the word model 3 that outperform all others in simulation during RL fine-tuning phase fails to reach the target. This demonstrates that robustness during the self-supervised phase predicts what works in the real world and not a win rate from RL training. Next, an open-loop navigation in imagination. The quadrotor flies with real observations, then after 2.5 seconds, we cut off all sensors. The word model must navigate purely on imagined observations, shown as the imagined depth and predicted position by the magenta arrow. Fidelity degrades over the imagination horizon, but the model never hallucinates a path into an obstacle. Thank you.